We're going to look into chapter 5.6, which relates to inequalities within one triangle. So the first theorem that we need to know is the corollary to the triangle exterior angle theorem, which is going to tell us that the measure of an exterior angle of a triangle is greater than the measure of each of the remote interior angles. So in this case, angle 1 is our exterior angle, whereas 2 and 3 are our remote interior angles. Now let's just say for a second that angle 1 is 120 degrees. Then that means that this angle here would have to be 60. So that leaves 120 degrees for these two angles. Since every angle within a triangle has to be greater than 0 degrees, that means that neither of these can be exactly 120. Both of them have to be less than 120, which means that they are both less than the measure of the exterior angle. That's what the corollary is trying to show us. So what we know here is that the measure of angle 1 is greater than the measure of angle 2, and the measure of angle 1 is greater than the measure of angle 3. Now, how are we going to apply this to a problem? Let's take a look at problem number 1 in the book here. It says, why is the measure of angle 2 greater than the measure of angle 3? So the first thing that we know is that by given, segment BC is congruent to segment DC. So you can see that we've got those marked off with our congruency markings. Now, what does that mean for us? It tells us that triangle BDC is an isosceles triangle, which then tells us that angle 1 and angle 2 have to be congruent to each other by the isosceles triangle theorem. So the next thing that we can learn is that the measure of angle 1 is equal to the measure of angle 2 because of congruency. So when we look at angle 1 as compared to this triangle now, we know that angle 1 is an exterior angle of triangle ABD, which means that angle 3 has to be less than angle 1, and angle 4 has to be less than 1, again by the corollary to the exterior angle theorem. What that then means is, since angles 1 and 2 are congruent, or equal measure, and 1 is bigger than 3, that means that 2 also has to be bigger than 3 by substitution. Now in theorem 510, we're going to learn that if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So what that means is if xz, so we're going to identify xz with the green line, is greater than xy with the blue line, then the angles across from them also have to correspond to them. So if xz is longer than xy, then that means that angle y has to be greater than angle z. Because since we're going to assume that this is the longest side, that means that it's across from the biggest angle, or the largest angle. Since this is what appears to be the shortest side, that means it has to be across from the smallest angle. Now again, we're going to take a look at how can we apply this with a problem in the book. It says a town park is triangular. The landscape architect wants to place a bench at the corner with the largest angle. So which two streets form the corner with the largest angle? Where would this architect want to put this bench at? So what we've got is, this is Hollingsworth Road, and then we've got MLK Boulevard, and then we've got Valley Road. And we know that Hollingsworth Road is 175 yards long, MLK is 105, and Valley Road is 120. So what that tells us is that since MLK Boulevard is 105 yards long and it's the shortest road, that means it's across from the smallest angle. Since Valley Road is 120 yards, which means it's the middle, it's in between the largest and smallest, that means that across from it is the middle angle. Then with Hollingsworth Road, Hollingsworth is 175 yards long, making it the longest side, which means it's across from the largest angle. So again, what we're looking to do is find a place to put a bench at the corner with the largest angle. So we know that the largest angle is across from Hollingsworth, so that means that MLK and Valley Road are going to be where we want to put the bench. For theorem 511, all we're going to do is reverse what we just learned in 510. In 510, we learned that if you've got a long side, that's going to be across from the largest angle. To reverse it, we're just going to say if we've got the largest angle, then across from that is going to be the longest side. So in this case, what we see is that we've got angle y is greater than angle z. So if angle y is greater than angle z, then that means that the side across from angle y is going to be longer than the side that's across from angle z. So we know that side xz is longer than side xy. So again, how are we going to take this and then apply it into a problem? So which choice shows the sides of triangle TUV in order from the shortest to the longest? In this case, we've got angle U is 58 degrees and angle V is 62 degrees. So that means we need to find out what is the measure of angle T. So remember that we've got 180 degrees in a triangle, and we've got 58 accounted for here and 62 accounted for there. So when we go to figure out how many degrees T is, all we're going to do is figure out, again, that we've got 58 plus 62 plus measure of angle T is equal to 180, and so that's going to leave us with 60 degrees by the angle, or by the addition property of equality. So now we go ahead and write in our 60 degrees here, and now we can start to figure out which one is the largest angle based on the degree measurement. So 62 degrees is the largest angle, which means the side across from it is going to be the longest side. So that means that TU is going to be the longest side. Medium angle is T because it's 60 degrees, so that means that UV is going to be the medium side, and then 58 degrees is the smallest angle, so that means that TV is going to be the shortest side. So the shortest segment again is going to be segment TV. The medium segment is segment UV, and the longest segment is going to be segment TU. We're now going to look at the triangle inequality theorem. So for the triangle inequality theorem, again we've got our triangle set here. The sum of the lengths of any two sides of the triangle is greater than the length of the third side. So what this means is that if you think about a ruler, if you have a ruler that's 12 inches long, and then you have another ruler that's say 9 inches long and another ruler that's 3 inches long, if you lay those two on top of the 12-inch ruler, they're going to correspond perfectly to it, which means you can't form a triangle because the two shorter sides don't give you an angle to get up off of the 12-inch ruler. That's what we're doing here, is that if you've got the long side here is 5, then the two other sides put together have to have a measure or a length that's greater than 5. You can see here that we've got a 3 and a 4, so we've got 7 inches total between those two sides, or 7 units between those two sides, which is going to be greater than this 5 units. You can see here on this one that if we take, again, the blue side and lay it right next to the pink side, we get a measure that's greater than the green side. If we take the blue side and lay it next to the green side, we get a measure that's longer than the pink side. And then we would also see that if we lay the pink side next to the green side, we get a measure that's longer than the blue side. What this means is that we do, since all of these pairings of sides are longer than the third side, it means that we can make a triangle out of those sides. So let's take a look at how we can use this. Can a triangle have sides with the given lengths? Explain. So we've got 3, 7, and 8. So what we want to do is we want to decide, can the lengths 3, 7, and 8 form a triangle? So what we're going to do is we're going to take 3 plus 7, and 3 plus 7 has to be greater than 8. So 3 plus 7 gives us 10, it's greater than 8. Then we're going to take 7 plus 8, we're going to take the second side and the third side, and those have to be greater than the first side. So 7 plus 8 greater than 3, and 15 is greater than 3. Then we've got 8 plus 3, so the third side plus the first side has to be greater than the second side, and that gives us 11 is greater than 7. So since all 3 of those check out, all of those pairings are greater than the third side, that means that this can be a triangle. 3, 7, 8 can be a triangle. Now let's look at 5, 10, 15. What we want to do is take the first and the second side, and we want to add those together. And we get 5 plus 10 is greater than 15. Is 5 plus 10 greater than 15? What we get is that 5 plus 10 is 15, which is not greater than 15. So this cannot be the measure of a triangle. Basically what you can do is you can take the 5 and 10 and lay them directly down onto the 15, but you would not be able to get the angles. They would separate as you try to angle up from that third side. For problem number 5, we're again going to be looking for possible side lengths. And this time we're given if two sides of a triangle are 5 and 8, what are the possible lengths for the third side? So what you have to do here is you actually have to think about this in terms of what if 5 and 8 are the shorter two sides, and what if 5 and 8 are the longer two sides? So what that would give us is if we think of 5 and 8 as being the longer two sides, then the last side would have to be shorter than 5. So to find that side, we're going to subtract the two given lengths. So what we get is x is greater than 8 minus 5, so x has to be greater than 3. Then if we think of these lengths as being the shorter sides of the triangle, then when we add them together, we should find the upper limit. So x would have to be less than 5 plus 8. So what we get is x is less than 13. So our third side length has to be greater than 3, but less than 13.